All right, so you've got this idea of coterminal angles down in your notes. Definitely a good one for the notes because it's one that it doesn't come up all that often. The concept comes up a ton, but you tend not to think about the name of it all that much. So it's good to have in your notes so you can go back and remind yourself what it all means. And so the idea of coterminal angles is that since they finish at the same location on a circle, it also tells us all sorts of other things. Like I can then figure out, in this example, 300 degrees and negative 60 are coterminal angles, because if you go around counterclockwise 300 degrees, that's the same as going clockwise 60 degrees. You end up at the same place on the circle, which means that you can know that the sine of 300 degrees is going to be the same as sine of negative 60 degrees. And the cosine of 300 degrees is the same as the cosine of negative 60 degrees. And since all of these are at the same location on the circle for them to be coterminal, how far apart are coterminal angles? Well, they would be 360 degrees apart, or in radians. What's a full circle in radians again? 2 pi. Although, we could even go around the circle over and over again. I could do like 360, I could do that twice. I could go 360 to 720 around. You know, we could keep going around and around. So technically, it would actually be like 360 degrees times n, where n is some integer number, or 2 pi times n. That's getting into the technical side, but basically, if we can add 360 degrees many times and still get to the same place, then you know it's coterminal. That's sort of an idea. And so taking a look at that, we can see for each of these angles what's going to be coterminal with each. And so for this first one, number 1 is at 60 degrees. So we're looking to see what other angles are coterminal with that angle. Well, one way we could do it is we could go around a full nether circle. So we could add 360 degrees to that. What is 60 plus 360? That would give us 420 degrees. Of course, I could keep going around from there. I could go around another 360 past that. So that would basically be going around twice in our circle. Okay, so if I take 420 and I add 360 to that, that would give me up to 780 degrees. I could keep adding 360. And I could come up with an infinite number of coterminal angles going that way. But it's not just going up. I could also go around the other way. I could go into the negatives. Interesting how it flips like that and jumps. All right, there it goes. So that'd be like subtracting 360. Well, what's 60 minus 360? Be negative 300 degrees. I could even subtract another 360 from that and get to a negative 660. Now, for this problem, I actually only needed to just give one of those. And there's, of course, many more options besides those that I could give. But those are all examples about how I could get some of those. So, using that as an example, go ahead and do 2, 3, and 4. Come up with an angle of your own that's coterminal with each of those remaining 3, please. Yeah, so this is now then a set of different examples, all of them just doing the same kind of thing. We're adding 360 one or more times, or we're subtracting 360 one or more times. That gets us to coterminal angles. And remember, the beauty of these is that we know, for instance, with all of these angles that we wrote down on number 1, every single one of those angles, the sine will be the same. The cosine will be the same. The tangent will be the same. All of those values of those trig ratios are the same because they really are the exact same location on the circle. And so we're going to be using that idea today as we get into graphing cosine. Because that's our next shift with this information, is seeing how we now graph those functions that we've been finding so far this year. So you just received a number of graphing grids. The first one is what you see up here right now. So you're going to be able to just copy the graph as we make it here together. Now in order to make this graph, I need to know what values to plot. And I actually have all of my cosine values already on paper. I got it in the form of the unit circle, and I got it in the form of the table of values. For me, I'm going to use the table. So break out your table of sine, cosine, tangent values. And we're specifically interested, of course, in the cosine values. So that's where we're going to be focusing our attention here. All right, so when we go to make this graph now, the first point I'm going to plot is the first column in my table, which is 0 degrees has a cosine of 1. So that means I go over to my graph, go to 0 degrees, and, oops, I did not plot that at 1. I plot that and plot it up at 1. There we go. And so that's our first point. It's at 0 over up 1. All right, the next one. We need to plot a point at 30 degrees and root 3 over 2. Well, now we got to think a little bit, right? Because, like, first of all, root 3 over 2. Where do we plot that? Probably going to be easier to have that as a decimal, right? So we can actually calculate that value. Do the square root of 3, divide it by 2, and it gives you a value of about 0.87. Looking ahead, we're going to need that for root 2 over 2 as well. So let's make note of those two values right now so that we have those going forward. Root 2 over 2 equals about 0.71. And so if I'm now going to be trying to plot this point, I got to go 30 degrees and 0.87. Well, I can estimate the 0.87 now, but where's 30 degrees? Well, we got to figure out what our scale is going up by. And on these graphs of cosine, oftentimes you're really having to think about what's the scale. So notice, of course, we know that 0 degrees is here and 90 degrees is here. Now, how many pieces is 90 being broken up into? Go and count it on your grid. It is 6 pieces, yeah. Okay, so what's 90 divided by 6? That's 15. So that means each one of those hash marks is 15 degrees. So if I want to get to 30, that means 30 degrees then must be 2 hash marks over. So this is where 30 is. And to plot that point then, I would go over that far and I go up 0.87 because it's root 3 over 2. 0.87, it's a little bit below 0.9, right? And you notice my y values are going up by 0.1, so I put it right about there. And so then for the next point, we're going to go and plot where 45 and root 2 over 2 is. So 45, that's going to be right in the middle. I'll use green for this point. And then the root 2 over 2, that's 0.71. So I go up to 0.7 and go just above it to see where that goes. And we can keep plotting our... So for instance, this should get you started on through 0 to 90 degrees. With that in mind, plot the rest of the table values into your graph. By the time you plotted all of the values from your table, this is what you should be looking at. Here's where each of those points go, so take a moment and make sure each of those points are plotted accurately. And then once we have each of those points plotted accurately, then we can go ahead and draw the curve that goes through. So notice how this curve ends up looking. It's definitely a curve. There's nothing straight about this. The closest it comes to straight is maybe this kind of a stretch in here, but it's not actually straight. It's just getting close to straight as it goes. All right, but then we only just filled up half of our graphing grid, and only half of our graphing grid. We still need to be able to fill the rest of it. We need to go out to 720 degrees. Well, this now is why we started class with coterminal angles. Because, let's take 30 degrees. Well, what's coterminal with 30 degrees? Well, we could add 360 to it, right? What's 30 plus 360? 390, which is this point right here. And because it's coterminal and it's the same point on the circle, we know that the cosine of 390 degrees is going to be root 3 over 2. Or in other words, that 0.87. And so I can go ahead and plot that point then up at 0.87. And because we're going to find that all of these are coterminal, I could take the 45, add 360, 60, add 360, 90, add 360. Because they're all going to be found that way, we can then see that this graph must just repeat itself. And so the graph from 360 degrees here is going to be exactly the same as the graph you made from 0. So go ahead and repeat that pattern with the same points. And when you repeat that pattern and carry it all the way out to the edge, you get a second cycle of the graph in there, and then this is our final answer. This is our whole graph of cosine, specifically cosine of theta, from 0 to 720 degrees. A few hints going forward as we take a look at the other graphs we're going to be making. We're going to be doing them on those smaller graphing grids. I don't really want to have to deal with every single time plotting root 3 over 2, root 2 over 2, and a lot of those little detail-y points, right? And so as we go forward, now that we've seen what the big graph looks like, if you can keep this shape going, that is the wave shape, really what you'll need to do in order to plot it is really just focus on the 90-degree intervals. And if we focus on those 90-degree intervals, you'll notice that this graph is following a certain pattern. Because it starts at the top, and it goes to the middle, the bottom, then back to the middle, and the top, middle, bottom, middle, top. And if it kept going, it would keep going, top, middle, bottom, middle, top, middle, bottom, middle, top, middle. It just keeps repeating the same pattern. So really what you need to know is that the graph of cosine is a wave like this, and that it starts at the top of the wave. If you know that, a lot of these actually get very straightforward to be able to work with. So we're going to see that in action here. We're going to be graphing y equals a negative cosine of theta. So go ahead and write this equation down above the first of your smaller graphing grids down below the big one. And while my x-axis is labeled, my y-axis is not. Well, we actually have a little bit of freedom to change what we go up by on the y-axis. But for our purposes here at the very start with graphing these, I'm just going to assume that they're all going up by 1s. And I'm going to do that for each of these, where they're all just going to be going up by 1s. Basically the default if we don't label things. So really we're looking at this kind of a thing. Alright, so I'm graphing negative cosine of theta. Now I know what cosine of theta should look like. Cosine of theta, based on the work that we just did, should look like this. Goes top, middle, bottom, middle, top. And that's how we would make the graph if I was just doing a plain old cosine. But I'm doing negative cosine. When I make a function negative, what's it do to my graph? It flips it or reflects it. Either way, it means the same thing. Specifically, across the x-axis here. So it's basically flipping it upside down, reflecting across the x-axis. That means instead of starting up at 1 then, I'm going to put my first point down at negative 1. Now, if you really want to, you can go ahead and plot more points in here. But I don't want to, and I don't think you want to, so I'm not going to do it. I'm going to go straight to 90. The cosine of 90 normally is at 0. Well, if I take 0 and flip it upside down, that is, I make it negative, it's still 0. And so that point stays the same. It's still going to be at 0. Okay, at 180. Notice normally at 180, I'm at the bottom. I'm normally at -1. If I flip that upside down, I flip it across the x-axis, I end up at a +1. Basically, I'm taking a -1. And I can keep doing that with the remaining points, and then I can see what my graph should look like. And just from those, I can then draw it in. Now, when you draw it in, remember the graph you're making. It's a wave. It should be leveling out at the top and the bottom, not coming in straight. And so that then is what your graph is looking like on this. Of course, without the red, we don't need all the red in there. All right, and on this one, once again, I'm assuming that I'm going up by 1s on my y-axis here. All right, so this is 2 times cosine of theta. I'm multiplying my equation by 2. Well, in all the previous functions we've dealt with, when we multiplied it by 2, what did it do to the graph? So the 2 in this case is a vertical stretch, which if we kind of think about what should be happening with my wave, it means that a wave that used to just be this tall is now going to be this tall. It's got to be stretched out to be twice as big. So let's go ahead and start plotting some points. Normally, for cosine, I put my first point up at 1. Instead of up at 1, it's got to be up twice as far, so it's up at 2. And then at 90, we're at 0. Well, if I stretch 0, 2 times 0 gives me 0, so it didn't change, right? And 180, where's it going to be at 180? That's normally at -1, so yeah, 2 times -1 gives me -2. And so then we can plot all of our points, and then with those points plotted, go ahead and draw your graph. And then you have your graph of 2 times cosine of theta. Exactly the same as cosine of theta, just going up and down 2 instead of up and down 1. Something we'll be talking about more and more as we go on, and especially as these things get complex, is that really what you'll see is it's like there's this undrawn line that actually later we're even going to draw in at the top and at the bottom. And basically your graph is just this wave bouncing between those top and bottom lines. And it's just a matter of where those lines are. Of course, we can shift everything about the graph too, which is what's going to happen here. So the +1 does exactly what it did with every other function we've ever seen and moves it up 1. Now, there's a couple ways we could think about that in terms of actually pulling that off here. I could take each of those points and actually add 1. So instead of my first point being up at 1, I'm going to put my first point up at 2. My next point at 90. 90 is normally at 0. Well, I would do 0 plus 1. So that moves it up. At 180, well, that's normally at -1. -1 plus 1 would give me 0. And I can keep doing the exact same process, get each of my points. So then we draw in our curve. And again, as you look at this curve, again, thinking about some of those invisible lines, notice here, that's actually the midline that I just drew in. So it's like in this case, the line that goes through the middle of this graph, that used to be the x-axis, it's now up there. It's now up at 1. And so you notice the graph is now going above and below that. If I really wanted to complete the picture with those lines and seeing what they're doing, I could even draw those top and bottom lines in like I had in that last picture. And you can see that our entire graph exists. All of the points that we just plotted for the 90-degree intervals, they all land on one of those 3 lines. They're either on the top line, the middle line, or the bottom line. And that is going to be true for all of these. All right, next graph. Go ahead and write down this equation, cosine of theta minus 90. And again, we think about what's happened in the past. Whenever I've had a number added or subtracted inside with x, of course theta works the same, it's moved it sideways. It's moved it in the x direction. This is going to do the same thing. The minus 90 specifically is going to move it which direction? Left or right? Minus moves it to the right. Yep, it's that annoyingly backwards one. And so that means that instead of putting my first point here at 0, 1, I'm going to move that point to the right 90. So I'm actually going to put that first point over here at 90. And I'm getting kind of tired of saying, well, normally the point is here, and so I'm now going to take it, I'm going to move it over, and having to do that for every single point. And I've done enough of these cosine graphs where I got a nice idea of the rhythm, right? Because that first point that I plotted was the top. Well, on all the cosine graphs, after the top, I went to the middle, and then to the bottom, and then back to the middle. And so I know what all of those are doing as I go along. Now, in this case, though, that's gotten me most of my graph. But we do still need to know what's happening over here. What's happening between 0 and 90? Well, that same wave is still going on. It's those coterminal angles, just now we're looking at the negatives that have shifted right to become positive. And so because it's still following the same pattern, think about what happens if you read the pattern from the right. So I start in the middle, and then I go bottom, and then I go middle, then we go top. What comes after top?
Middle.
It's got to be going to the middle, yes. And so then I can know that that next point goes in to the middle. Then that tells me where to draw on the rest of my curve. Right, having done each of those individual little graphs, you can now do the whole thing all at once. And it now looks big and complicated, but notice every single part of this equation is something that you've already dealt with individually. We're just going to put them all together. I'll give you some tricks on how to do so. So, you know those dotted lines that I was talking about earlier where the top, the middle, and the bottom are? When you start looking at a graph like this, that can make your life so much easier. So in this particular graph, where is the middle of my graph going to be? Well, the middle, the only thing that can change the middle is how far we move it up or down. Well, that has to be the number that's added or subtracted on the end. That's the plus 1. That's the one that changed the midline. And so the plus 1, that's my midline. So the first thing I'm going to do on my graph is I'm going to draw in a dotted line at my midline. And then I need to know, where do I put the top and the bottom lines? Well, that's how tall the wave is. Well, remember that happened from the number multiplied out front. That was our vertical stretch. Technically speaking, that vertical stretch is actually called the amplitude. I'm not going to make a big deal out of that today, but I do want to let you know that it's called amplitude. It's a fancy name given to a vertical stretch on cosine. All right, so that means, though, that since it's a -2, really it's a 2 for the amplitude, because amplitude's always positive. That means I'm going to be going up 2 to get to the top line, and down 2 to get to the bottom line. All of that relative to the midline. So from the midline I went up 2, from the midline I went down 2. From there, I really only need to figure out one more thing, and that's where do I put my first point. And I don't need to worry about the 2 or the plus 1 anymore, because I just dealt with those by drawing in those lines. The minus 90. Well, remember before that told us that we started by going right 90? So it's going to put my first point over at 90. Now, some people will actually put in another dotted line for that one. They'll put in a dotted line over at 90. I often don't, but if it makes you feel better to do so, it makes it easier for you to track, feel free. And then the negative, well, the negative told us that instead of starting up at the top, we started down at the bottom because it flipped it upside down. So my first point goes on the bottom line there at 90. Once you've drawn on that first point, all you need to do is look at where are those top, middle, and bottom lines. Because every point, remember, goes on one of those three lines. And if I just put a point at the bottom, where does the next point need to go? Middle. Because every single time we graphed one of these, from the bottom we went to the middle. And so I put it on the midline for that next point. And if I just went bottom and then middle, where's my next one go? And if I were actually seeing the graph, I'd be seeing it doing this. Obviously it's heading upwards, right? So it's got to be going to the top next. And so my next point then goes at the top. Okay, and if I just put a point at the top, where does the next point go? It's got to go back to the middle, yeah. And so you notice it's following that same pattern of middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, over and over and over again. It's just a matter of finding out where we start. And from 0 to 90, what are we doing there? Well, again, if it's at the bottom here at 90, the next point's got to be in the middle. And so by knowing what each of them do individually, we can know how to deal with them, and then by drawing in those dotted lines, it makes it easier for us to do it. Because without the dotted lines, we have a tendency to forget to go up the right amount, or we tend to lose track of something. So I'd always encourage you to draw in those dotted lines because they help you be much more accurate when making these graphs.